One of the cool ways you can visualize these quadric surfaces is via what are called slices. So you see here's a quadric surface, and it is kind of wrapped around the y-axis because now this time the y is negative. If I let x be a constant, then what I can do is see what's going on while x is constant, like constant planes, and kind of visualize it whenever I don't have my computer handy. So when x is a constant, if you look over here, that makes the rest of this a hyperbola. And as you can see, we have hyperbolas here. And so that if you vary the value of x, you get a different hyperbola. Now, if we look at y, so now I'm going to look at this down the y-axis. This is now the zx plane, looking at it like this, right? If I vary y, see y here this time, we're going to make this a constant. Now the rest of this will end up being a circle. And so we get circles out of this, circles of varying radius. So if you want to figure out what this looks like, just by looking at the actual equation, this is how you can do it. If I let z be a constant, then you have hyperbolas in the z direction instead, like that. And so if I look down in the z direction, I get that. Now, this really helps with saddles or hyperbolic paraboloids, where if I have z equals x squared minus y squared, if I allow y to be a constant, so where are we at? Where's the y-axis? Y-axis is over there. If I let y be a constant, I'm looking at it, y is a constant, so we're looking at slices in the y that are parallel to the x-axis. So we have parabolas that are opening up, but as soon as I let x be constant instead, then we have parabolas opening down instead, like that. So that's how this works. And then if I let z be a constant, now we have, if z is a constant here, we have hyperbolas in the xy plane, well, parallel to the xy plane, like that. Stop. Like that. Okay, so this will help you visualize it whenever you don't have the technology handy. These are called slices.